Hello, and welcome to today's video on Kirchhoff's voltage law and AC circuits. Now, Kirchhoff's voltage law, or KVL, simply states that the sum of all voltage drops and rises in any loop of a circuit is equal to 0. Take this circuit for example. The power supply is producing 10 volts, and the first resistor is dropping 4 volts. But what about the next two voltages? An application of KVL will yield these two equations, one for each of the loop of the circuit. From there, it is easy to see that the two voltages are minus 6 volts. The good news is that KVL and DC works pretty much the same as KVL and AC. However, AC voltages are represented many different ways. Fortunately, these voltages here can be used exactly the same as a DC voltage, and we can use these equations to convert between them. But what about KVL with waveforms? Well, we must convert to a form in which addition and subtraction can be performed. To do this, we convert to an RMS voltage. Here, the RMS voltage is 15 volts. Then we simply take the phase from the waveform and combine it with this voltage to make a polar equation. This is known as the phasor form. Now that we have the phasor form, we can convert to a rectangular equation using rectangular and polar conversions. These are the equations to convert from a polar equation to a rectangular one, and these are the equations to convert back to a polar equation. Let's look at an example. Here, the power supply is given by this waveform, and the voltage across the capacitor is given by this waveform. Now, just as before, we're going to convert to the polar form using the same process. In this case, the power supply is equal to 20 over root 2 volts in the angle of 45 degrees, and the capacitor's voltage is given by 10 over root 2 volts in the angle of negative 45 degrees. Then using those conversion equations, we find that the power supply is given by 10 plus J10 volts, and the voltages across the capacitor is 5 minus J5 volts. Then we simply apply KVL, which yields this equation here. We simply substitute in the voltage that we just found, which is 10 plus J10 minus 5 minus J5, which gives us 5 minus J15 volts. Then using the exact same process but in reverse, we can eventually convert back. This gives us this equation here, which is the waveform across the resistor. Thank you for watching, and I hope you learned something.